Hello. Today I will show how transformation of variables can help satisfy some of the assumptions that we make about regression. For this, we will use a dataset of star cluster SIGOB1. Here, the first variable is the log of effective temperature at the surface of the star. The second variable is the log of light intensity. We want to see how log of light intensity is affected by the log of effective temperature at the surface of stars. We see that both variables are in scale measurement here. We draw a scatter plot of these variables and see that 4 outliers are present. These outliers are approximately below 3.6 in the log of temperature axis. These outliers are pulling the regression equation in the negative association direction, even though majority of the points are showing a positive association between these two variables. One solution could be to delete these 4 outliers. To do this, we go to Data and select Cases. We select only the points for which log of temperature variable is above 3.6. After setting this condition, we see that in the data view, another variable is created named filter. Also the points for which log of temperature variable is below 3.6 are crossed out. That means, only the points above 3.6 in the log temperature axis are selected in this dataset. Now we again draw the simple scatter plot and see that the outliers are removed. If we draw a regression equation in this scatter plot, we can see that the regression line goes uphill, which means it shows a positive association between the two variables in question. However, instead of deleting the outliers, we could take these points into consideration to draw a polynomial regression. Let us fit a quadratic regression and see how well that fits the entire data. To select the entire data again, we simply go to Data and select Cases and then choose all cases. Otherwise, we could simply delete the filter variable to do the same. Now, to create the quadratic term of log temperature, we simply go to Transform and Compute Variable and write down the numerical expression of a square term and name it 2. We can set appropriate label for it and make sure that it is in scale format. We now fit a polynomial regression of log temperature and its quadratic term. In the output window, we can see the estimated slopes -33 and 4 for log temperature variable and its quadratic term. To assess the normality and the independence of the residuals assumption, we draw the normal PP plot and scatter plot of the standardized residual versus the standardized fitted values. We see that the plot indicates that the standardized residuals do not deviate much from normality and the mean is approximately 0. In general, the residual plot looks random. Now, if we want to see the fitted curve or the regression line, we go to Analyze and then Curve Estimation. Here we choose log of light intensity as dependent variable and log temperature as independent variable. We unselect linear and select quadratic, ask SPSS to produce an overtable and plot the model including the constant in the equation. This will produce the curve in the output window. Notice that this curve now represents the entire data much better than the straight line we have drawn earlier. However, interpreting the beta coefficients in the polynomial model is much harder than the straight line regression model.